Okay, so during this short video, I will be showing how to go from monolith application to a cloud native platform. And when I say cloud native platform, I mean a place where people from outside, like third parties, can provide custom blocks that can be plugged into this platform. I will be using a fake scenario about conferences. So imagine like a company is in charge of providing the software for users or customers to create their own conference sites and to publish them into this platform, right? So we will be looking at all the transition from a monolith and all the pain points that we had in a monolith to go to a cloud native approach with microservices, and then to a platform as a product or as something that you're going to provide as a service to customers or to users that are outside of your company, right? So let's get started by looking at how the monolith looked. So the monolith was basically a single web application, quite large, built in Java. And when you looked at the code inside this application, it was kind of like split into halves. The first top half in this case is all the cross-cutting concerns about how to deal with users, identity management, security, how to deal with multiple tenants, in this case, multiple customers that wants to host their different conferences, how to isolate those, how to execute async jobs or cron jobs, these kind of like notifications that are recurring in time and you can set up to happen in the future. All these things in general, they were not related with conferences at all, except from some little bindings where you need to say, okay, conferences and users are related in this way, right? But in general, all that code uh, can be solved by some other tools. For this application, it was all built in, right? Another thing that we had in that, it's like core services, of course, more conference related services, such as sponsors and agenda, speakers, attendees, sessions, venues, all these kind of things. And a mechanism to allow these external people to provide custom user interfaces for their sites. Also, we have some extension mechanisms, like they were called plugins in general, and basically this is like third-party custom behavior that you can add to your conferences for dealing with certain things that are not provided by the platform. So at some point you thought, okay, I want to extend how sponsors are displayed. I want to sort them in a different way. So you create a plugin and to provide it to the platform. And then it was also considered as an extension point, the fact that you cannot code to the platform itself. So for some more complex use cases where plugins were not enough, basically you can ask, or a customer can ask to add custom code to the platform. The problem with that is that because this is just a single runtime, all the other conferences that were hosted, they will share that. And the moment that you bring custom code and custom libraries, that becomes a mess. And in Java is well known to have those kind of limitations. There are some ways to work around those limitations, but all those ways are extremely complex. This application's source code was stored in a single GitHub repository. And because of that, if somebody like a team wanted to change how the sponsor mechanisms work, was tied to the entire release cycle of this application. So we had a pipeline that for every change will create a new release. And if you make a small change, you will need to go through all this big complex pipeline in order to just get that out. So if you have multiple teams, that becomes a real problem. The source code in general was not modular. And by that, I mean that, okay, we had different modules, but were all tied to the same release stream. And that's where the problem was in general. All the custom code that customers require us to put into the platform tend to stay. That means that the complexity of the platform grows and grows and grows, and it's very difficult to limit that. Plugin mechanisms were not optimal, as I mentioned before, because they target the entire platform and the ecosystem is like very, very fragile in that way. Reusing things becomes really, really harder. Let's say that for a conference, you need a custom sponsor behavior, but because it was a plugin and the plugin mechanism didn't allow to reuse that, it got really, really complex. And then the problem that got us really, really thinking about going to the cloud is scalability, right? If you have a conference platform that it's a monolith and you want to scale it to scale different conferences for different purposes, you can. You just need to scale the entire thing, right? And that's definitely not cost effective. That definitely didn't work, right? You need to scale everything. Even if you have a conference with 2 attendees and a conference with 10,000 attendees, you need to scale everything. And that's definitely what motivates us to move forward. But let's get started looking at some code and how we can start improving this situation. So let's say that our source code for our application is in GitHub, right? I have a repository that contains a Spring Boot application just to demonstrate how the monolith would look like. And also I will try to demonstrate how we can use JenkinsX in order to improve just the monolith, right? So let's work with the monoliths first to understand what JenkinsX can give us if we are in this situation. So I have the source code of the application here. It's just a Spring Boot application. I can just run it here, run just to see that the application is running and it is kind of working and how it looks like. So this is starting, and I can go to my browser and go to localhost. This is running locally, and I can see here that the application basically is just a single thing. There are just these different sections of the application where we have the agenda and the sponsors. That means that if I want to change this section, I need to go to the source code that is in that repository, change that section, move it forward, just change whatever I want, change the agenda and whatever, right? Now, what happens is that if I have another conference, right, like it's similar to this, but it's not the same, and it also needs sponsors, in order to get that functionality, I will need to go to the first repository, copy the source code for sponsors, and put it in the second. That's very not efficient because if something changed that was shared by both, now I need to make the same change in these two repositories and keep them in sync if I want to maintain that, if I want all my conference to leverage that. So that's definitely not a good practice. And so if we want to start reusing different sections and different places, we should start thinking about how we can split this. But for now, what we can do is we can say, okay, how do I take my application that it's running locally and how can I run it into a Kubernetes cluster, right? First of all, I want to mention that I have a Kubernetes cluster already created here, and I have JenkinsX installed in this, right? So if you don't know about JenkinsX, you should go to jenkinsx.io, x.io, and you can figure out here how to install JenkinsX in a cluster. As you can see, I'm using Google Cloud, and I'm using the free trial that gives me 250 pounds, I think, or $300 free credit, so you can create clusters. And that basically helps me to get the cluster here with JenkinsX deployed without paying anything for just giving it a try. I totally recommend you to do that because you will learn a lot from that process. So I've installed JenkinsX in this cluster, and now I want to take my application that it's running here locally in localhost, and I want to put it inside that cluster, right? So let's do that. And you do that by importing this application to JenkinsX again, because I've installed JenkinsX already. I have JX command line in here, right? So I have JX command line, and I can say from inside the source code, that I've cloned from GitHub, I can say JX import. And this is basically, it's going to configure JenkinsX. It will create a new pipeline for my application. And JenkinsX will be in charge of building and releasing this application and propagating the artifacts that were released into a Kubernetes environment. The first thing that it will do, it's going to decorate my source code with some artifacts, some files that are required in order to run all this pipeline. Some of those files, as you might imagine, will be a Docker file for creating a Docker image for my application that I can go there and fine tune. So application was imported. Now I will have a pipeline running, building my application. And I can definitely take a look at what's going on there. So it's building, it's cloning the source code, it's going to build the Docker image, build the Maven project and all that stuff, right? I can also see the logs for those pipelines and for all the steps inside the pipeline. So I can follow what's going on there until it gets deployed. So I can see that here, in this case, it's setting up some credentials, so it downloads the stuff. And we will see how it builds the Maven project, how it builds the Docker image, it's building the Maven projects. Now it's how it's going to tag the GitHub repository to create that release, and how it's going to push that release into the Kubernetes cluster. It's going to push this release by sending a pull request to an environment. JenkinsX used the concept of GitOps in order to sync environments and maintain the state of these environments. So if you go to my GitHub account, you will find out that I have a repository for my staging environment in this JenkinsX installation. And basically what it has a Helm requirements file that basically lists all the services that are installed in this place, right? I have no conference monolith right now here. I have some other services, but I will receive a pull request here. As soon as my pipeline finish building my new service, it's going to send a pull request in order to promote that to the staging repository. When all this happens, we should be able to have our application up and running, and we should be able to access this application that is running in the cluster. So you can see here that it's doing exactly what I mentioned. It's sending a pull request to the staging environment, and we should be able to see the pull request here. It says, okay, I now have a new service that it's called Conference Monolith, a new application, and I want to add this into the environment. JenkinsX, please run a pipeline on top of the environment to verify that this pull request is green and everything is working. As soon as that's validated, it will be automatically merged to master, and that basically will put into the environment the application. So let's take a look at that. So basically we are now need to wait for this pipeline to run and for this pull request to be merged. While we wait for this pull request to be merged, we can move on. Pull request is now merged. There are no more pull requests. Now one more pipeline will be executed, which is the pipeline, the promotion pipeline, which is basically the pipeline that's looking into master of the staging environment in order to apply the changes into the environment. As soon as we get that, we should be able to do get applications to see which applications do we have in our environment. And as you saw before, I had some other services already running, but a new application should pop in here saying, okay, Conference Monolith is here, and we should be able to go and access that one. Yeah. We can also check the pods that are running in this environment with kubectl get pods jx staging to see if our service is being deployed. It's not being deployed yet. The pipeline for the environment is still running. Yep, the pipeline is still running. Let's get the applications. Now I have a new application and I have a new URL to access this application. By default, JenkinsX, if it puts a new application on the staging environment, it will give me a way to access, right? There is still no pods up and running. That means that we can check which pods are running in the staging environment in order to see when our application is up and running, right? So it started 20 seconds ago, 29 seconds ago, and we are waiting for the liveness and the readiness probe to be up and running. Now they are up and running. That means that I can do J applications again. I should be able to see that I have one of one pod there. So if I access now the application, I should be able to see the same application that I had running locally here, right? By doing this, we gain kind of like a lot of things already, right? So this is not perfect. We still have a monolith. We have a single place where we're running everything. But JenkinsX, what did for us, it basically defaulted all the things that we needed to create in order to deploy this to Kubernetes, including the Docker files, including the pipeline to run all these steps and to build all these projects. It uses the concept of build packs, so it detected that I had Spring Boot application and it defaulted all these files. And it also creates the Helm chart for packaging our application and all the Kubernetes manifests that are required to deploy my service into Kubernetes, right? Like to deploy it and to expose it. So we have that now. So the main thing to see here is that it also created a tag and a release. So as soon as I have a release here, I will be able to have a new version out there. For every change that I will make, it will create a new release and we will have a continuous stream of releases for my monolith application. So that's a big win now, right? And we definitely need to understand this in order to understand how we can split this into microservices. Because if we don't have this methodology and this, kind of like automated and defaults that help us to go faster, when we split this into multiple repositories, let's say that we have 50 repositories, it becomes a nightmare to manage them all in different ways. So we need to have a methodology and we need to have a set of practices to follow for each of these building blocks, these pieces, in order to create conferences that are now distributed, right? So let's do that now. Let's start thinking about how we can split this application into multiple pieces. Okay, so now if we start thinking about distributing these conferences, and again, this is not the conference platform, this is just how a single distributed conference will look like. So we started doing this exercise in order to find the right shape for the conferences and how the services will be split. And the first thing that you will notice is that we definitely divided like the source code and we try to be more modular. So we don't get blocked if we are just changing one piece of the application or the conference in this case. Like for example, if we change the sponsor service and the sponsor service is used by multiple conferences, we wanted to make sure that that shared code is in a separate module and that can evolve independently, doesn't need to be linked to the conference itself. So the first thing that we did is we created different Git repositories per service, and that helped us a lot to go faster because again, different teams with different people assignated to these teams were able to iterate quite faster. The second thing that we did is we moved to the infrastructure, all the things that are not really conference related, right? Like identity management, security, single sign-on. We definitely didn't want to have that too close tied to the conference. And if we need some bindings, then we will create a very, very small service to do those bindings inside the conference. So we split this into two different things, and then we focused on the conference and the conference main building blocks. As I mentioned before, now we were more modular. We have different pipelines for each service, and that means that we could have different release streams for each of these things. They can evolve independently. We thought about extensions, and extensions will come as functions in general. So our main way to extend a conference behavior is just by selecting some functions that can be easily created, or just add some other event-specific services. So if a conference is so specific, so special that it requires its own services, okay, that's fine. Just tell me which are those services, and we will just put them in the context of that conference. In this case, we find out that, of course, like reusing became easier because different conferences can reuse the agenda service, right? And just to build their agendas and to use the same code and the same services for that. The second thing, it becomes easier to scale, basically. We will just can scale sponsors in different ways, can scale agendas in different ways. We can scale completely different conferences in different ways, right? The main problem that we faced is that, of course, the overall complexity grew. And if you're looking at this and you're saying, oh, okay, now we have tons of repositories, we have tons of pipelines, everything can go wrong. That's kind of like the first preconception of all these things. But the more that you automate, the more that this becomes simpler and simpler, and you can go faster instead of being slowed down by the single monolith. Of course, all this infrastructure, usually it's mostly provided by cloud providers, so database message brokers. The only thing that we need to know from the services is how to connect to those things. And the other thing that it became quite apparent, and that's why we have the dashed line here, is that now we have a set of services that are composing a conference. So we need some kind of service aggregation to say, okay, all these services belong to this conference. And in order for this conference to run, you need to have all these services in these versions, right? So in order to do that, we start analyzing different options, and let's switch to see a little bit of code on how we did that. Okay, so if we split our application into microservices, we will end up having different Git repositories, right? So that's what I did for this example. So I split the conference monolith into three different repositories, into three different modules, into three different services. So I have the conference side here, which is the front end plus the place that the backend that is in charge of calling all the other services in order to display to the user. I have conference sponsors, that is just the REST service, and conference agenda, it's another REST service providing the agenda functionality and the sponsors functionality, right? So I did the same thing that I did with the monolith before. I've just imported this into Jenkins X. It decorated my project with all the files that are required to execute the pipeline. And as you can see here, I have 10 releases. I have 18 releases of the sponsors and 22 releases of the agenda. That shows that the agenda, I've been making more changes into the agenda repository, and that can evolve like on its own. It doesn't need to wait for the sponsors to be released or the conference side to be released, right? Because I've imported all these things already to Jenkins X, I can do JX get pipelines to see that the pipelines for these services are already being set up. So conference agenda, conference site, and conference sponsors. And as I mentioned before, we have the environment pipeline as well, which is the staging environment in this case, that is being executed every time that we want to promote one service to the staging environment. I can also do JX get applications again. And by default, I configure Jenkins X to only expose the conference site as the main entry point for the conference. That means that if I go here, this is the conference site, I should be able to access that service, right? And this is how it looks. Now it's the same thing that as we had before, but now the conference itself, it's composed by 3 different blocks. These are not micro frontends. This is just different blocks calling different services. In this case, this place here, it's calling the sponsor service, and this place here, it's calling the agenda service. As you can see, they all have different versions. So the site is version 11, sponsors version 18, and agenda version 22. As you can see also, this relates to the releases that we have here in GitHub, right? We have, take a look at the releases, we will see release 11, and that's pretty much what we have here in the UI, right? So because we are deploying stuff into the environment, like the staging environment, we will see as soon as we have a new version, it will be promoted here. We will see how it looks. So that's very useful to see if everything is working. But as you might wonder now, a single conference, this conference, in this case, Jenkins Works Conference, is composed by 3 services. And there is nothing in these pipelines that understand the relationship between these 3 services. That means that in order to run this conference somewhere else, we need to, in some way, aggregate these things. So in order to do that, what I created here for this example is I'm using Helm in order to package these 3 things together. And the versions of these 3 things, and provide a single version for the conference itself, right? So I have a repository, which basically represents this aggregation. And this conference, as you can, this repository, as you can see, it's basically a Helm chart, which basically depends on the 3 main services. So we have conference agenda, conference sponsors, and conference site. This basically says that for running this conference that we were looking at here, somewhere else, you need this version of these services. If we want to replicate exactly the same behavior that this conference is providing there, you need this version of these services. And I can basically now have a pipeline to build this Helm chart and to release it as well. So as you can see here, that we have 9 releases of these. So we have 8 or 9, we have 9 configurations of our applications with different internal versions. What I've also configured to do is I'm using something that is called UpdateBot, which basically allows my pipeline for each of the individual services to notify some other repositories that there is a new version about this, right? So if you take a look at the pipeline itself, I've extended the default pipeline, which is just this line, that is defaulting all the steps for building a Maven project. And I've added this, which is basically saying, okay, every time that these pipelines run and we create a new release, we will take that version and we will notify this repository, conference Helm chart, that there is a new version available. That notification happens by sending a pull request. That means that if we take a look at this one here, we will see that there is a new pull request saying, okay, we have a bunch of new versions for our services. Right, and if we take a look at here, we will say, okay, there is version 22 for the agenda, there is version 18 for sponsors, and there is version 11 for conference site. Right? Those were quite old, but maybe stable versions, right? So at some point, we can create some rules to decide when to merge this pull request, or we can just make that, responsibility for the owner of the conference. So we can say, okay, yeah, this looks good. This looks good, it's building, now it's checking that the pull request is okay. But because we have no rules, this is not going to be merged, so it's my responsibility. So I will merge this pull request. That means that the pipeline will now run, and now we have a new release for this Helm chart. What that allows me to do is I can just go and pick the release number, and I can go to an empty cluster and deploy exactly the same application that I have running here in my staging environment, where I can run a bunch of tests and just do some user testing as well. And then when I said, yes, this is stable enough, I already have a package for that application that can run in a cluster that doesn't have any Jenkins X installed in it. So that's quite cool because now we have a way to package our applications and move to different clusters. And again, because we are leveraging Kubernetes and Helm, that means that we can put it in a different cloud provider if we want to, and that should work. So with that in mind, let's take it up another level, right? What happens when you want to build a platform for hosting these conferences, right? Like more like a product. A conference itself, it's quite like, it doesn't change, it doesn't mutate. It always will have this shape. What happens when you have conferences with different shapes and we want to provide a platform to host those conferences? That's what we're going to take a look at right now. Okay, so far we have discussed about the disadvantage of having a monolith, how we can split that monolith or at least one of these conferences into different services that can have their own life cycle and they can have their own release stream for each of these services with pipelines and all the things that will allow different teams to work on this independently. We also have discussed about how to create and aggregate and package a conference with a set of services pointing to each of the individual services version and have a version for that package itself so we can take it out and move it to a different cloud provider and deploy it independently of Jenkins X or any of the other things that we have there. The third step is to create a platform to host these conferences, right? We have these complex applications now that are packaged using help charts. Now we want to provide a platform that can operate and manage these conferences that will have different shapes, right? Like one conference have 3 services, like the one that I've showed before, but we can have more complex conferences that have tons of 20 services, for example, and we will have 20 pipelines for building that conference, and we will have a different Helm package for deploying that more complex conference. So we need a platform, we need a set of components that will understand, first of all, what a conference is, in order to understand how to deal with the life cycle of each of these conferences, how to scale them independently, how to configure, security policies or traffic control policies, and how we can integrate these conferences and the whole thing with third-party, software that it's already running in the cloud provider. Let's say that you want to use AI for some of your conferences. Okay, what exactly do you need in order to integrate and bridge the gap between these services? In order to do all these things, the first thing that we tend to do is we tend to say, okay, what is the main thing that this platform is going to host? In this case, is our conference. So there is an extension mechanism in Kubernetes that it's called custom resource definition, that it allows us to define these custom concepts. And then we have operators, which are the components that will look for these concepts, and then they will try to match the declarative state of that resource into the cluster. So those are usually called operators, and the operator here it's called conference operator because it will deal with conferences, right? So the first thing that I did it was created the custom resource definition for a conference itself, and I created the conference operator as a service, right? And because again I'm a fan of Jenkins X, I've imported this into Jenkins X so I can make changes on the behavior of this component, and the pipeline will deploy the new version every time. And again, the main objective of this component is to monitor and to manage conferences that we have out there. So you can find the source code for this operator here. And the first thing that I did, as I mentioned before, is created a custom resource definition for defining what a conference is, right? And this is basically a special type of resource inside of Kubernetes. And this is basically going to extend the Kubernetes API saying, okay, now I know about conferences. So you define name, you define a type, and then you define nothing else, just a short name, so you can just get these resources. And also you can define some additional columns so we can get this resource, we can see more information. We'll see that later. So as I mentioned before, I imported this into Jenkins X already. You will see that it has a Docker file as well. Again, it's a Spring Boot operator. And it will be in charge of monitoring conferences and also understanding how the services of my conferences are running. We can then create conferences, and we create conferences by creating new instances of these custom resource definitions that we have. In this case, I created Jenkins World USA, and it has the dependency of these 3 other services that I already have running, right? And it has some extra metadata there, right? So if we take a look here, we can do again applications. And the operator itself, in this case, it also exposes like a user interface, so you can at least monitor what are the conferences that you have and how the conferences are running and if they are healthy or not. So I can access the dashboard because we don't have any conference yet. That means that, for example, if I go to here to the terminal and do get conf to get all my conferences, I have no resources created. I have no instance of this type, right? I have no instance. I have no conference, right? And I can create a new instance of that by deploying this definition of this conference, in this case called Jenkins World USA. So I can do kubectl apply -f CRDs Jenkins World San Francisco, and it will tell me, okay, there was new conference created. So now I can do get conf, and I will get that. So you can see here, it has the metadata, but it also is decorating this like with the state of the conference, and it's also exposing the conference itself. As you saw before, we were accessing the old conference with conference site, but in this case, I am creating a new entry, like a new route into the ingress in order to put the conference name into the route, which is more, it's nicer. So I can access that conference in there. But I can also, again, access to the dashboard to see the conferences. And now, because I created a new type, I can expose and understand a little bit more about my conference, right? I know now that the conference has 3 services and that the overall status of the state of the conference is healthy because I have all the services and all the pipelines already linked to it here. So the operator is also in charge to integrate with JenkinsX in this case. So as soon as I run a pipeline of any of the services and the pipeline fails, I will just see the change of the status of the conference to not healthy, like unhealthy. It's not down, the conference is still up and running, but there is something in one of the services that it's not being built, so it will cause problems down the line. I can clearly do that. And also I can create more conferences and manage all these conferences. I can create another one. So for example, let's see, are these Mars? I can create another conference and see that the operator will just refresh the state and it will try to start understanding what are the services that are needed for this conference to run. And it will say, okay, I have this conference, CDF conference site. It's not there. It's not, I cannot find it, and I cannot find any pipeline for that. So by default, this conference is down because not all the services are up and running. In that way, I can create different rules to check the conference status. I can define very conference-specific ways of exposing conferences URLs, for example. In this one, I can just click there and access it. I can also here link to the source code of each of these individual modules and the releases, because again, I have a version. So I can know exactly that this conference that is running here, it's built using this source code. It's deployed using this Helm chart as well. So it gives me full traceability of, okay, I have this conference that it's in high demand, how is it being scaled, how it's being built, and if I need to make a quick change in order to say, okay, I need to fix something in the agenda, I know exactly where to go, and I know exactly that a new version will be generated. And as soon as that version is ready, I can go and click promote, and I will get it up and running to our users. I can also add more operational side of things here. Like I can definitely add a button here to say, okay, just shut down this conference, and it will automatically remove the route to access to the conferences, so nobody can access that conference anymore. So hopefully that makes some sense. This is quite a complicated subject, and the main idea behind creating this example is to give you a reference where you can just go and copy the configurations, maybe not the implementation, but the configurations that allows you to get, from the monolith to microservices, from the microservices, the aggregation to creating a Helm chart, and then an operator that basically now understand about the domain specific concept, in this case, that it's a conference, and how it can aggregate and monitor, the state of the services, the state of the pipelines, and make sure that you can report and understand how these applications are running. And again, at this point, you have a platform where you can host multiple conferences and you can scale and move conferences to different cloud providers. So there are tons of other things that you can do with this, but this is just an example just to point you in the right direction. I know that that might be quite a lot for a lot of people, but I hope that it can serve as pointers for you to go and and ask more questions and dig deeper into the different areas of what I demonstrated here. But thank you for watching and stay tuned.